Okay, is the cause, and in this video we'll be looking at the general trend in the halogen series, the properties that shows regular variation with increasing atomic number down the group 7 of the periodic table. So we're looking at this one after the other. The first is that number 1, all halogen have colors, and their color becomes darker as you go down the group. Like fluorine is pale yellow, chlorine is greenish yellow, that's a darker color than pale yellow. Iodine, bromine is reddish brown or orange. Iodine is black in color, and acetine also is black. So that their color becomes darker as you go down the group. Next, the melting and boiling point of this halogen increases steadily as you go down the group. Now, this is the reason why we have an increase in boiling point down the group. The intermolecular force is the one always responsible for boiling point. But in the group 7 elements, van der Waals force is the dominant intermolecular force among them. And the more the molecular mass, the stronger the van der Waals force. So as you are going down the group, as the number of electrons increases or the molecular mass increases, the strength of van der Waals force also increase at the same time. That means as you are going down the group from fluorine to iodine, there is an increase in the strength of van der Waals force, which leads to increase in the melting and boiling point of the halogen series. As you can see from the screen, fluorine has melting point of -220 and boils at -188. Like that, as you go down the group, you see that there's a progressive increase in melting point and progressive increase in the boiling point of this halogen. Then the physical states of this halogen improves progressively from gas to liquid to solid at room temperature. What's also responsible for this is the intermolecular force. They all contain intermolecular van der Waals force, which becomes stronger with increase in molecular mass, or if you like, with increase in the number of electrons. So because the molecular mass of this halogen increases down the group, their physical state also improves down the group. Like chlorine is gaseous at room temperature, bromine with higher molecular mass is liquid, and iodine with even more molecular mass is solid at room temperature. So you can guess what will be the physical state of astatine. Even though it's radioactive, you know that it must be solid because it's going to contain stronger van der Waals force than those elements listed above. So the higher the intermolecular mass, the higher the molecular mass, the stronger the intermolecular force, and the more improved the physical state. All right, the boiling point of hydrogen halides follow this order. Hydrogen fluoride comes first, next to hydrogen iodide, to hydrogen bromide, to hydrogen chloride. Ordinarily, hydrogen fluoride should have come last because the molecular mass of hydrogen fluoride is the lowest, which means the boiling point should also be lowest, since boiling point has to do with the molecular mass, which is the one that determines the strength of the van der Waals force. But among all these compounds, hydrogen fluoride contains hydrogen bonding instead of van der Waals forces, and hydrogen bonding is a stronger intermolecular force than van der Waals force. So because hydrogen fluoride contains intermolecular hydrogen bond, the boiling point will be higher than the rest of the compound in that series because they have only van der Waals force inside. So that's why hydrogen fluoride is coming first. But hydrogen iodide, hydrogen bromide, hydrogen chloride follows that order. They all contain van der Waals force, and they have the molecular mass, they have the van der Waals force. And Hi has the highest molecular mass next to HBr, next to HCl. That's why the remaining trend follows the regular order in terms of boiling point. But hydrogen fluoride was separate because it's not having van der Waals force. Instead, it is having hydrogen bonding. So that is why hydrogen fluoride is having an unusual high boiling point. Number 5, the solubility of halogen decreases down the group. Fluorine is very soluble. In fact, it reacts explosively with water to form other compounds. When fluorine reacts with water, like it's going to form HF, and oxygen displaces oxygen from water because it's even more oxidizing than oxygen. Fluorine is the most electronegative element on Earth, and it's most oxidizing, most reactive non-metal on Earth. So because of that, it can displace oxygen from water to give us hydrogen fluoride plus oxygen. So it dissolves very well in water. Chlorine dissolves moderately in water. Bromine dissolves sparingly in water, and iodine dissolves so slightly in water. To make iodine dissolve, you have to add potassium iodide to aid the solubility of iodine in water. When you add iodine solution to any compound containing starch, it gives you a blue-black coloration, as you can see in the video. Blue-black coloration with the bread, and blue-black coloration with the compound, the liquid inside that beaker containing starchy material. So solubility of the halogen decreases as the molecular mass of the halogen increases. Alright, the acid strength of hydrogen halide also increased down the group. Hydrogen fluoride is the weakest acid, or hydrofluoric acid is the weakest acid among the halogen series, and the reason is because hydrogen fluoride contains hydrogen bonding, which prevents the hydrogen from being released as hydrogen ion. But hydrogen bromide, hydrogen chloride, hydrochloric acid, and HI, they are very soluble in water, and apart from that, the hydrogen can be released into water readily. So hydrogen fluoride is the weakest acid in that halogen series. Then the reactivity and the ability to oxidize decreases down the group. That means fluorine is the most reactive element in the group 7, and by extension the most reactive non-metal on Earth. As you go down the group, there's a decrease in the reactivity. The reason is because the atomic radius increases down the group, and this makes the electronegativity to decrease. The higher the atomic radius, the smaller the electronegativity. So that's why fluorine having a small size is actually the most reactive, because it's the most electronegative in that group 7 element, in that group 7 table. Displacement reaction of halogens. Ordinarily, we know that a more reactive element will displace a less reactive one from the solution of their salt. This similar thing happens in the group 7 element. Fluorine, which is the most reactive element in that group, can displace all other halogens from their salt. For example, ordinary fluorine can react with sodium chloride and displace the chlorine to give us sodium fluoride and chlorine gas. Chlorine can also displace iodine and displace the bromine, because chlorine is more reactive than the two of them. So when chlorine reacts with Ki, it gives us KCl plus I2, not ordinary I, plus I2. It should be plus I2 plus I2. Alright, so here should be plus I2 because halogens are diatomic in nature. Alright, bromine cannot react with KCl because we are expecting bromine to displace chlorine, but chlorine is more reactive than bromine. So because of that, bromine would not be able to displace chlorine from a solution of potassium chloride. Hence, this reaction will not occur. It will not occur because bromine is less reactive than chlorine. Hence, it cannot displace chlorine from its salt. Iodine is the weakest oxidizing agent in that group, taking the fact that astatine is radioactive in nature. You can also write this equation like this. Instead of writing the salts, I can say chlorine plus bromide ion. Bromide ion is a sort of bromine. Can be potassium bromide, can be sodium bromide, can be anything. So if it's written this way, it means chlorine is reacting with a sort of bromine. That's the meaning of Br minus. I minus is a sort of iodine. Cl minus is a sort of chlorine. Alright, so here now, chlorine reacting with a sort of bromine can displace bromine to form chloride salt, and bromine gas will be displaced. So in that place, you'll be getting a brown coloration because bromine will dissolve in the water and give you a brown coloration. Chlorine can also displace iodine from its ion. The ion, don't forget, means salt. So chlorine is more reactive than iodine. So a normal chlorine gas can displace iodine from its ion to give us a chloride ion, and iodine supposed to be a gas which will dissolve inside the water to give us a brown coloration or orange coloration. So here now there will be orange coloration in the water. That's how you know that the reaction has taken place. And iodine, you get a brown coloration when the iodine is displaced. Alright, but if you want to react iodine with a sort of chlorine, this would not work. It will not work because iodine is less reactive than chlorine. So iodine cannot displace chlorine. See, chlorine is existing here as Cl minus. That means it's a salt that contains chlorine. So iodine cannot react with a salt of chlorine to displace chlorine. So that is why there will be no reaction in this place. That reaction is not feasible. That reaction is not possible. That reaction is not spontaneous. So that is why you see no reaction in that place. So the summary of all we have been saying about the periodicity of halogen is that as you go down the group, there's a decrease in the reactivity, there's an increase in atomic radius, the size becomes larger as you go down the group, and there's increase in the number of shells. So number of shells increases as you go down the group. There's a decrease in the power to attract electron. That is, there's a decrease in electron affinity. There's a decrease in electronegativity. So there's a decrease in the power to attract electron to form negative ions. And there's increase in melting and boiling point. You know why? Because there's increase in intermolecular van der Waals forces. Then finally, the color of the element tends to get darker as you go down the group. So these are the periodicity or the trend that was observed, or that were observed rather, down the group of the halogen series. God bless you.